Hello.
Good afternoon, everybody. Thank you for coming to see us on what is, I believe, the second to last slot of the entire summit. We appreciate your being here. My name is Matt McEwen. I'm an Associate Director of Cloud Development at AT&T, focused on the AIC AT&T Cloud that leverages OpenStack, as many of you know.
And my name's Elise Iden. I'm a systems engineer at AT&T as well, also working on AIC.
And this afternoon we're going to talk a little bit about AT&T and its involvement with FirstNet and what we do to support that from a test automation and NFV perspective. And so the first thing that we want to talk about is, to set the stage, is what is FirstNet? FirstNet is a government initiative in the US that was commissioned following the 9/11 tragedy and the serious implications that that had on our first responders' ability to communicate and to respond to events that happen. So we're talking about things like police and medical first responders, fire departments, the ability for them to respond in a timely fashion to incidents is incredibly important and can mean the difference between life and death for people that are in trouble. So the US took that very seriously, and the charter of FirstNet is to build the first high-speed, nationwide wireless broadband network dedicated to public safety. AT&T was selected to implement the FirstNet network, which we are very proud of, and which we are working very hard to meet the demands of and to ensure that it is everything it needs to be. We take that very seriously. And it's important to know that when we're talking about a dedicated network for first responders, we're not just talking about cell phones. That is an important component of it, but there's quite a few other use cases. Things like smartphones, body cams, connected vehicles with broadband access, and cameras in their own right, augmented reality, health monitoring for first responders, indoor location tracking so that we know where people are as they save the lives of others. So FirstNet is a big initiative for AT&T, and how does it impact AIC, our cloud? First, AIC is going to have dedicated sites, that is to say dedicated clouds, in support of FirstNet, as well as dedicated, to begin with, a dedicated AIC release. So an entire release of our software focused exclusively on FirstNet. Likewise, we have a team of individuals who support FirstNet from a development and a deployment standpoint, an architecture standpoint, a group of folks whose job it is to make sure that FirstNet is successful from our cloud's perspective. We are refining our process and our tools to be able to push out patches to our cloud very frequently, but in a very controlled way to ensure that when changes need to happen in AIC in support of FirstNet, that they can be done safely and quickly. There is a heightened focus on security analysis and ensuring that security is not a first-class citizen, but the first-class citizen of our cloud from a requirements and a functionality standpoint. As you know, the security of a network dedicated to first responders is of life-threatening criticality. So that is a real focus of ours. And finally, there is a focus on early platform testing, taking our automated testing and shifting it even farther to the left than what we've done to date with our test automation, especially from a VNF perspective, understanding that our FirstNet clouds are going to be heavily VNF focused, the VNFs being in support of the FirstNet broadband network. And Elise is going to walk us through some of the ways that we've approached FirstNet test automation.
Thanks, Matt. So in order to achieve that early platform testing, we want to sort of revamp how we're doing VNF tests within our automated deployment pipeline. So if we're doing things the way that we currently are, which you can see on the left side of the slide, our VNF testing takes place after the development process, after the system test process, and totally into the end-to-end testing kind of world. So in doing that, there are some obvious challenges. We are creating really a lot of unnecessary delays, a lot of additional testing, and we're creating a lot of additional process to resolve the defects that we just didn't know about until a lot later in the process. So in order to fix that, logically, we want to start shifting our VNF testing to the left, so earlier in the development process. The most important part of what we wanted to do here was make an extensible framework. So we want to be able to accommodate the needs of our real experts, which are the teams that are handling the VNFs and AT&T, so that they can have the test cases that they need earlier in the process. This whole thing is a part of our Aqua resource testing framework, which stands for AIC Quality Automation. And we're calling this a crash test dummy of sorts. So what is a crash test dummy? So if you think about it, a real crash test dummy has a human-shaped resource, and then that human-shaped resource is used to perform tests for vehicle safety. So we want to make sure that the humans and the cars can interact together before we actually put them together. Exact same thing for us. So instead of the human-shaped resource of a crash test dummy, we have a heat template that can spin up our VNF resource topologies and then perform functional tests against that so that we can test whether the VNFs and our AIC platform are going to work well together before we actually put them together in our end-to-end testing. So to do this, I put the thing on the wrong slide. In order to do this, we are using the OpenStack project of Shaker. So if you're not familiar with Shaker, it's a data plane network testing, performance testing tool in OpenStack. And so Shaker was really, really good for us to just sort of get this off the ground immediately without changing anything too much. So some reasons for that: it has a custom built image, so we can include any testing tools that we want to actually include. It also has some native iPerf3 tool sets so that we could use those right out of the box and get going. And the most important thing is that it already uses heat templates, which we already had for our VNFs, so we could just sort of plug and play with very minimal changes there. So some of the benefits of doing this might be a little difficult to read, but bear with me. So first and foremost, each team gets to dictate exactly what their crash test dummy looks like and what it acts like. And these use cases are totally representative of what each team needs. So that really enables us to get that communication going early with the VNF teams that we're talking to. So opening lines of communication is never a bad thing, especially when it's so early in a process that usually happened at the very end of the process. So big benefits there. Another way that we're going to make this really work for us is by doing a non-blocking asynchronous testing gate in our Jenkins. So by doing that, we're not holding up the deployment by running these tests, but we're enabling us to identify and resolve some potential defects a lot earlier. So doing that really helps us with frequent testing, automated testing, portable testing. All of that works with this asynchronous gate. The testing is also very scalable. Using Shaker natively, we can spin up hundreds of compute nodes and run these tests on those. And then the heat template that we can use and we can run natively in Shaker, again, one of the most important things about the tool itself. So all we have to do is decorate these heat templates to create the crash test dummy and then leverage existing Shaker tools, and we're good to go. Lastly, and definitely most importantly, is the collaboration that we really built into the process. So the VNF teams can certify their own use cases, help get those tested earlier, and they do that completely independently of us. So it's really going to be easy to use moving forward. So this is sort of a quick breakdown of the features of our first crash test dummy that we did with our mobility team, who has done a lot of our VNFs, and honestly, most of them. So you can see there on the left, we have a lot of networking tests first off. So we've got service chaining, we've got jumbo frames, we've got simple ping tests. And then on the right, we have some of the things that we're really hoping to work towards, like VLAN trunking and DPDK. So what these are is a lot of the common challenges that our VNF teams are facing. We want to address them as early in the process as possible so that instead of the typical tests that they would run, again, at the end of that pipeline that I mentioned, they get to run them before. So again, relating it back to FirstNet and what Matt was saying, another priority that we have moving forward is that we want to make sure that we really prioritize the FirstNet critical VNFs as the first things that we're doing, first crash test dummies that we're creating. So here's a pretty high-level overview of the architecture that we're using for this. So we're kicking everything off with Jenkins, which we already use in our automatic deployment pipeline. So that's sort of a given there. We have our quality gate running within Jenkins. Then we use a Docker container so that we are ready to move to CLCP, our containerized local control plane, which you guys probably saw on Monday at the keynote. So very exciting stuff. On from there, we dynamically spin up a heat template, which will create our shaker controller VM, which really operates as the home base for the rest of the process. So from the shaker controller VM, we're going to use the crash test dummy heat template to spin up our test topology and all the related resources that go along with it. And then from the shaker controller VM, we're running the tests that we provided as parameters to our Jenkins job. We run the tests on that topology. The results go back to the shaker controller VM, and then the results persist on the Jenkins VM. So then on the right, we have just sort of a sample architecture of what we create when we're using the mobility crash test dummy. So there we have 2 compute nodes, for an example, each with 2 VMs on them. They're connected with our iPerf tools. You can see the sort of dotted lines. And iPerf is native in Shaker, so that's a way that we can roll that into our custom Shaker image that we're using. And if we wanted to use anything else beyond iPerf, we can also do that and just roll it into the image as well. In addition to a few of the helpful things that I already mentioned, so the custom image that we can use in Shaker, the native networking-centric testing tools like iPerf, and the fact that it natively uses our heat templates, there are also a few more. So it allows us to configure some thresholds that will make the gate pass or fail, and that's identified by the actual VNF testing teams themselves. And then we also have traceability that's native in Shaker, so we can better pinpoint exactly where potential defects lie. And then lastly, we have native Shaker tests that can give us a nice kind of visualization of performance, which you guys will be able to see in our demo coming up. So we're going into the demo. A few things first. There are a few ways that we can actually execute these tests. Number one is Jenkins. Like I said, we would prefer to do it this way generally because it's the way it is in our pipeline. You can also deploy it straight from the Docker container. And what we're going to do right now is just use an Ubuntu VM for the Shaker controller VM for flexibility's sake. So obviously, as you start to kind of dig deeper and deeper into the process and you need more and more configuration, and it becomes less and less orchestrated. So everything still functions the same. So the second thing is, once the topology is spun up and we have all of the resources stacked on our cloud, the tests can range from very, very simple to very, very sophisticated. So the one I'm about to show you right now goes on the former end of the spectrum. It's very, very simple. It's just going to be some L2 east-west tests of different size packets going between VMs, and we're going to be running on one single compute node. So this is going to be sort of like our baseline tests that we're going to run as part of our deployment process. So instead of relating to a specific crash test dummy, we would be relating to all crash test dummies because this is functionality that any VNF would need. So also, while this is running on a single compute node, like I said, we can scale it up and run it on hundreds of compute nodes if we so choose. So let's get started. There we are. Okay. So, is this running? It's not running. There we are. Cool. So first, we see that we're going to have our stack spun up by our crash test dummy as soon as we start running it. And there it is. It has a unique identifier after the name, so just in case we want to spin up multiple stacks, we definitely can, and there won't be any naming issues. And here you can see our topology that's dictated by our heat template, which is not a crash test dummy. It's just a native L2 heat template that already exists in Shaker. So there are two instances, like we discussed in the architecture. You've got the networking between them, which uses some underlying contrail services in Neutron. And you'll be able to see that we have that master and servant on one single compute node, like I mentioned. There are our resources. And master and slave on the single compute. And then because this is a Shaker native test and we're using iPerf, when we go to the results file, which we are about to do, you'll be able to see sort of a nice graph, which is great, giving us some packets per second data. You can see all the tests that we ran there. Dig deeper into our 9,000 byte packets. And Shaker provides all of this information natively. This is just a natively Shaker run test. So it provides us with all of this information. Now, we are about to see a test that would be run on an actual crash test dummy, this one specifically for our mobility group. Okay. All right, so we're starting with a clean slate, no instances, no stacks, nothing from the other test. And what you're about to see here is a more complicated topology. So instead of just one heat template, you're going to see 4. But we'll get into that in just a little second. You can see here that we are running on 5 compute nodes, so that's 10 VMs based on the architecture that we had just discussed. So what I meant with those 4 different heat templates, we have a base heat template that we're using to build everything upon. Then we have an L2 service instance heat template, an L3 service instance heat template, and then we have a final heat template which actually brings it all together and spins up our Shaker resources on the topology. So this was not possible until we did some extensions on Shaker, which is all a part of what we're hoping to upstream to Shaker ASAP. So with that, we made Shaker able to take in environment files, which is something that our crash test dummies did natively because of what our VNF teams wanted. It also can take in multiple heat templates, like in this case. We also added support for mixed flavors, and then, again, we just plan to upstream all of that as soon as we can. So here we've got some stacks already getting set up. One by one, we started with our base. Looks like our L2 is just starting to get up. Check out the topology. And they're just building one on top of the other. And we can see all the network elements in there as well. All the policies, all the other resources. Our L3 is finally up. And there is our Shaker stack. So there we can see everything there. We have our 10 different VMs on our 5 compute nodes. A lot more complicated topology than we saw previously with our L2 tests. And so once everything is spun up here, we're going to run, obviously, our tests on them. And so here we have a custom suite of tests. So it's some iPerf tests, it's some ping tests, it's some jumbo frames tests. So with all of those, it wasn't a native Shaker test. It's a custom test that we extended Shaker to do. So there we won't have the same kind of nice graph that we had, but it still has a lot of the same information that we would need. So now we have all of our resources up. There are many. And again, we could do this on more than 5 compute nodes, but it would be not as clear. All of our masters and slaves being spun up one by one. And there we go. Check to make sure nothing else is going to be spun up. And it hasn't. So here is our custom shaker test results file. Digging deeper. And again, we don't have the graph, but we still have pretty detailed logs that Shaker provides us with. So those are going back to our Shaker controller VM and then back to our Jenkins VM. And that's sort of the first steps of what we have here. We're hoping to build upon it and go potentially beyond Shaker, but Shaker has been very useful for us in this sort of proof of concept. So I'm going to pass it back to Matt with next steps.
Thank you, Elise.
Yep.
So this is a first step, and we want to build upon it. One of the first things that we plan to do back at AT&T with this framework is to partner more closely with our VNF owners across the company, keeping in mind that we intend this to be a tool that we can place in their hands so that they can run their VNF-focused tests on our cloud as early as possible. They, being the owners of the VNFs, have the best knowledge of how they should function. So by collaborating closely with them, we'll be able to jointly prove them out sooner. We want to incorporate the OPNFV yardstick application in as well. Yardstick and Shaker do different things, and we are interested in being able to use the tools, all the applicable tools available to us, to ensure that our VNFs meet all the criteria that we will hold them to. We plan to participate in the OPNFV community to discuss the different ways that the community can approach these problems, right? So this is a first step that we worked on. We want to share that with OPNFV and to collaboratively determine where to go next. Because this is not something that we want to go it alone on. This is something that we would love to collaborate very closely with other NFV users and vendors to advance the platform. We will contribute the enhancements to the Shaker framework that we've done, namely to be able to read the heat environment files in a Shaker test. And then finally, we want to contribute to the OPNFV testing labs. There is an OPNFV project called Pharos, which is intended to distribute out the load involved and the labs involved with NFV testing so that many participants can prove out that different layers in the NFV stack, from hardware up through SDN and cloud and VNFs, that they all integrate together correctly. We are, AT&T recently, I think actually last week, created a new open source focused lab in the T-Rex Tech Incubator in St. Louis, a startup incubator that has open source focused companies in it already. And we plan to leverage that lab, in addition to other open source collaborative uses, in part as a way that we can test OPNFV and NFV workloads leveraging Pharos in an ongoing way. So with that, what questions do you have? The lights are bright up here. If you have your hand raised, I can't see you, just yell it out. Yes?
What's, I guess, in terms of your inclusion of this as part of any sort of pipeline, what are the plans? How does that work?
In our own pipeline? Yeah, it's going to be a part of our full CD pipeline, so automatic deployment that will be happening after our verification testing. So it'll automatically be a part of that, and we'll have our baseline tests going kind of all the time, and then based on what VNFs we're trying to test for, we can sort of turn them on or off depending on what we need. Anything else?
All right. Well, thank you all very much for joining us today, and safe travels back home.
Thanks so much.